This is our third lecture of units and dimension. Basically, if you look at the syllabus of NEET, you will not get these topics under the units and dimension. Okay, but still we are discussing these topics over here because NEET reshuffle these topics under the another title, which is experimental methods. So the bottom line is we have to study these topics. We cannot skip it. Okay, so these are two instruments which we will just get the idea of them, how to get the reading out of them, how to use them for our numerical applications. Okay, this would be our basic motto of today's lecture. This is the today it's 19th of December. This is our third session. Let's start. I have already explained you the objective of today's lecture, so this slide is okay. Okay, this weightage. I hope you remember that it is a very important chapter for us. The reason being, it has high weightage, and the other reason is this chapter has very, very good questions to concept ratio, as I told you in previous classes also. You remember this thing?
Yes, ma'am.
That's cool. Now, let's come to the revision one. So I know that last class is, I think it arranged like a week earlier. So I want you guys to give me the recap of that class, whatever we studied in second lecture of units and dimension. Can anyone? Okay, Harshita, please. Anji.
Ma'am, we have studied about the significant figures and rounding off the digits.
Very nice. Yes, Gayatri, please continue with them.
Ma'am, we see a rounding off and significant figures. The zeros are leading zeros, trapping zeros, and trailing zeros. And we're calculating of
Yes.
significant
Nice detailing.
figures.
Good.
And the error, absolute error,
Very good.
relative error, mean absolute error.
Yes. Very nice. Good. Nice. Very nice. So yes, these two kits, actually some of the entire class, we have studied about significant figures, how to calculate the number of significant figures in the given data. And the second thing which we have studied is rounding off, a very simple discussion. Okay. Then the third one, which is very important, and that is error. We have studied the types of error. Can someone explain these types? Just, simple definitions or name. Anything can be okay. Besides Harshda and Gayatri, since they gave the idea. Anybody else? Please? Anyone? Come on, just involve in the, class interaction. It would be more appreciated. No? Okay then.
Absolute error.
Yeah.
Relative error.
Okay. Good, Shikha. Can you tell me more?
Percentage error.
Very nice. Yes.
Absolute mean error.
Mean
Very
absolute
good.
error.
Very good. Very nice. Very good. It's okay. Take care. So these are the three topics which we discussed in the last class. Now let's come to today's topic, which is propagation of error. As we know, we have four basic mathematical operations, like addition, subtraction, multiplication, and division. So for this particular topic, propagation of error, I will combine these four into two groups on the basis of their dealing. Positive and negative in one group, let's say group A, and multiplication and division in the another group, which we will call group B. Okay. So this is a very simple thing, not something that I'm going by books. This is just to let you know that we have two types of dealing when it comes to propagation of error. The dealing of group A is same, and the dealing of group B is also same. Okay? But they are quite different from each other. Let's discuss this group A. So no matter whether you have addition or subtraction in the given expression like this. Let's say I have x is equals to a plus b. Okay. And if I have x is equals to a minus b, so plus minus won't make difference when it comes to the propagation of error. If I want you to calculate the total error in x, okay, so you will always add the errors, always add the corresponding errors. Delta B is the error in the measurement of B. Delta A is the error in the measurement of A. Similarly, delta X would be the error in the measurement of X. Okay. So if you have delta A and delta B, you can calculate delta X by this simple thing. And even if I have minus over here, wait a minute, there is someone trying to get in. Wait a minute. Okay. So here, even if you have negative subtraction in your expression, you can also get the error in the same way. In errors, in the calculation of error, there is no idea of subtraction or something. There is always addition. You always add the errors. Is that okay?
Yes,
Hmm?
ma'am.
Yes, ma'am.
Okay. So that's cool. Let's come to group B, which is multiplication and division. For this particular group, you have to be very good at relative error. You know that concept, na? Relative error wala. So in
Yes, ma'am.
okay, in this expression, if you have like this, let's say y is equals to a dot b, okay, or you have y is equals to a by b. Now I gave you the relative error in a and in b also. And if I want you to calculate the relative error in y, so you will give me the answer like this. Like this. You just add the relative errors. Okay? Whether it's multiplication or division. As I said, when it comes to the propagation of error, there is no such concept like subtraction. You always add the errors. Is that okay?
Yes, ma'am.
That's cool. Let's solve few questions on the propagation of error. Okay? Let's move ahead. You have this question number 1. Basically, we have a cube and the mass and volume of that cube is given to you. I want you to calculate the density of this block. Can you do that for me? Is question clear to you?
Yes, ma'am.
Okay. So I'm giving you time over here. It's 17:59 right now. Solve it till 18:01. Okay. And once you got the answer, please raise your hand. I will ask you, but let's give chance to everyone so that they can solve the question. Okay. So anyone? Okay, Harshda. Anyone else? No? Okay, Harshda, continue, please.
Ma'am, can the answer be in the fraction or I have to calculate in the point?
No, fraction would be okay.
Okay, ma'am, as we know the formula of density is mass by volume.
Yes.
So we know that in division, error should be added.
Yep.
So delta x by x plus delta y by y. So I have did 0.3 upon 6 plus 0.2 upon 2. By making the LCM same, my answer is came 0.9 divided by 6.
Okay. So can you give me the expression of density? See, okay, that's very good, Harshada. Nice one. Okay, here you have mass and volume in a certain manner. Can I compare this equation like this? Mass is equals to, this mass is equals to m plus minus delta m. Is that okay? And
Yes,
when it
ma'am.
comes to volume, you can compare it to this format. V plus minus delta V. So basically, M and V are the true values. Delta M and delta V are the errors corresponding to mass and volume. Okay? Now, let's come to the density. Since I know that density is nothing but the mass per unit volume, so first calculate the true value, and that would be M by V. So when you make the comparison over here, you will get M is equals to 6 and V is equals to 2. Just substitute these values over here. 6 by 2 is equals to 3. Okay. So this is the true value. Now calculate the error also. Okay. Actually, there's a mistake. I wrote it as kg.
Ma'am, you're not audible.
Yes, ma'am.
Am I audible now?
Yes, ma'am.
Yes, ma'am.
And video is visible to you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Screen is shared perfectly, right?
Yes, ma'am.
Okay, that's cool. So let me know whenever you have this kind of trouble, right? Okay, let's start. So what I'm saying that if I want to calculate the relative error or the error in the density, I have to do this, right?
Yes, ma'am.
Okay. Just put the values. Delta rho is something which I need to calculate, but rho is something which I just calculated. It's 3. When it comes to delta m, you just need to compare it. So when you make the comparison, delta m would be 0.3 and m is 6. Just put the values. When it comes to delta V, it would be 0.2 divided by 2, right? Just solve it. And this delta rho would be 3 times of this entire thing. So try to solve it or just put it in the fraction. It would be 6 and it would 0.3, it would be 0.6, right? You will solve it, you will get 0.9 by 2 and it would be 0.45. Okay. So when I want you to write the expression of the density, you will answer me like this. Ki ma'am, density of this block will be 3 plus minus 0.45, okay, kg per meter cube. This is the right way to answer the question. Am I okay? Are you okay with this?
Yes, ma'am.
Yes,
Yes,
ma'am.
Okay, that's cool. Let's solve this another question. Here you have a rectangular block, let's say A, B, C, and D. You have the detail of length and breadth. Okay. I want you to calculate the area. Find the area. And your time starts from 1807 to 1808. Chalo, 1808. Come on, do it fast. You have just 1 minute. Okay, Harshita. Can anyone explain me? Okay, Harshita, just wait. Yeah, Shikha. Okay, Shikha. See, Harshita, I'll give chance to Shikha. Since I know that you are doing well, I just want to know other kids also. Okay? So don't mind me. Okay. Haji Shikha, please continue.
Ma'am, the true value is 8 and the
Yes.
answer is 8 plus minus 0.16.
0.16. Okay. See, very good. Firstly, the presentation of the answer is good since it is supposed to be in true value plus minus the error. True value is correct. Let's focus on the error one. I'm not sure about it. Let me check first.
Ma'am, it is
Okay,
1.6.
that's good. Very nice. Good, Shikha. Harshda, you also got the same answer?
Yes, ma'am. I only told 1.6.
Okay. So it's Shikha and Harshda. Okay? They solve this question. Nice. Good. Let's come to the solution of this question. We have length and breadth. Okay? So the basic thing is, let's put them into the standard form, which is nothing but L is equals to like this. Okay? That's how you represent the data. I know when it comes to the area of the rectangle, area is equals to length into breadth. Okay? So just calculate the true value first. And it would be 4 into 2, which would be 8 meters square. Okay? Now, it's time to calculate the error. And for that, we have the concept of relative error and that too of addition. That you will add the relative errors. Just put the value. Okay, area. Area you have over here is 8. Oh. Delta L is 0.4, 0.4 divided by 4. And 0.2 divided by 2. Okay? Just solve it. It would be 1 by 10. And it is also 1 by 10. It would be 2 by 10. Right? 1 by 5. 5 ones are 5, 6, 7, 8, 3.0, 1.6. Okay? 1.6. So the answer would be that area is equals to A plus minus delta A, which would be 8 plus minus 1.6 meters square. Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay. So should I call out your name or you would answer Miki ma'am? Yes, it's fine. We will do these kind of questions like Jennifer, Irfan, Aditya, very good. Divisha, Gayatri, Namrata, Misbah. Okay,
Ma'am, I
Mantusha,
have a small
cool.
doubt.
Yes, please. Please ask.
And in terms of subtraction, we have to minus the
Harshita, your voice is not clear to me. Can you come up? Can you please come again? Yes, ask. What are you saying?
case of subtraction of error, we have to subtract the error.
I think you are asking me ki even in the subtraction we are going to do addition of the errors, right? This is what you are asking?
In case
Okay, you are not audible.
in case
You're not audible.
and error, the subtraction.
Harshida, you're not audible. Can you please write it down in the chat? Okay, write it down. Okay, till then, let's come to the next concept, which is quantities raised to some power. See, there could be some complex equation also now in front of you. For example, I give you a relation like a raised to the power p, b raised to the power q, c raised to the power r, and d raised to the power s. So here I have multiplication, division along with the exponents. Okay, so this is a complex expression. Now, if I want to calculate the error in this situation, so the process is very simpler. Just come and just listen to it. Listen to me. It would be delta x by x is equals to p times of delta a by a. See, a and b are in multiplication, but they have powers to themselves also. So what you will do, you will bring that power into multiplication and write the fractional error. Okay, then put the sign of addition, do the same like this. Is it fine?
Yes, ma'am.
And this is very, very important because it has huge application even out of this chapter. Okay, it is not just confined to the dimension of this chapter only. Suppose I think you have come across a lot of questions like that you have a wire, you increased its length by pulling, there is a reduction in the area, calculate the change in percentile change in the resistance. So all of those kind of questions can be deal on the basis of this simple procedure. Okay, so make sure that you keep it in your mind. It is very important. And when I'm saying it is important, kindly note it down somewhere. Okay, it is very, very, very important. Is that okay? Hmm? Let's solve this question on the basis of this method which I just gave you. In an experiment, the percentile error occur in the measurement of physical quantities A, B, C, and D of 1%, 2%, 3%, and 4% respectively. Then the maximum percentage of error in the measurement X would be. And you have the relation of X with all of these quantities like this. Cool. You have 4 options over here. I will give you a poll. Kindly answer on that poll only. There would be no hand raised. You will not answer the in the chat and everything. Just answer on the poll. Okay? And within the time. It's 18:15 right now. Please answer me around 18:17. Okay, I'll give you 2 minutes. And I'm launching the poll. And I got the doubt of Harshda also. Ma'am, in subtraction method, we have to add the errors or subtract them. No, Ashta, you always add the errors. In addition, subtraction, you just add them in the absolute form, like delta A plus delta B. When it comes to multiplication and division, you are supposed to add their relative errors, but you always add the error. There is no concept of subtraction. Is that fine, Ashta?
Yes, ma'am.
Okay. See, the poll is launched. Kindly answer over there. Okay, you have just 1 minute to solve it. And please don't use the Google Lens, because lately in other batches, I realized that kids are using the Google Lenses to solve the question. And when I asked them to explain it, they were like, blah, blah, blah. I don't know. But, it is so visible to a teacher. So don't do that. Okay. Try to solve it by yourself. If you find it difficult, so let me know that particular points. Otherwise, how will I help you? No? So don't use it. Okay, Mishpa. And just let me know when you want to see the current one.
Ma'am, can you just show the options?
Okay, so Harshida, the options are like this now. Option A is 10%, B is 3 by 13%, C is 16%, and the D is minus 10%. Is the screen visible to you?
No, ma'am.
Okay, screen is not visible. Oh, I don't know what is happening. Is it visible now?
Yes, ma'am.
Okay. So can you guys please answer fast? Okay, I got only 3 votes. We have 15. At least put 10 votes over there. Are you okay now? Are you find it? Are you find it like? Are you understanding it or not? Just be very clear at this point. Are you able to understand this thing? What I'm teaching you, or is there any issue? See, be very comfortable, be very frank with me. If you find something difficult, if you find something, no, I'm not getting it, this is your class. You need to raise your queries. Otherwise, how would I get the idea, na, if you are struggling somewhere? So please let me know if something is, bothering you in academic perspective. Because if it is not challenging you, then why there are not the answers? Why there are only 4 votes? Right? I'm not talking about the correct one or the wrong one. You are trying to solve the question. That is important for me. So please tell me, is it difficult? Are you not able to understand the concept? Please.
Ma'am, not understood the concept.
So yes, that's cool. Just let me know. Otherwise, see, हम जैसे आगे बढ़ते चले जाएंगे. Okay. So I will explain you this concept via numerical. Just tell me ki before this discussion or before this slide, do you understand the entire topic? Whatever I studied, I've told you about the propagation of error. Is it okay?
Yes, ma'am.
Yes, ma'am.
Are you sure? Everyone?
Yes, ma'am.
Okay. So it's just this one. That's cool. I'll give you the explanation via this question. In this question, we have a formula over here. X is equals to a square b raised to the power half and c raised to the power 1 by 3 d raised to the power 3. Okay. Now question said there are some errors in calculating a, b, c and d. Since this x is the is a result of these four quantities, and if you made the error in measuring them, then there would be certain amount of error in x also. It's just that we need to find out that error. You have here the information about the errors in measuring these four quantities, 1, 2, 3 and 4% respectively. Okay. So the basic idea of solving these kind of questions is this: first you are trying to calculate the delta x, but what you would get? You would get delta x by x. Okay. When it comes to a square, so this 2 would be written like this, multiplication to the relative error of a, plus this half would be like this. Is it okay to you?
Yes,
Yes,
ma'am.
ma'am.
Okay. Okay. Since we just get the information about this thing, whether it's multiplication division or addition subtraction, we will always add the errors. It's a fact now. Okay. So you have this kind of expression over here. But in question, I do not have the relative error. I have percentile error. So we need to transform this relative error into percentile error by just multiplying the entire expression with 100 on both sides of the equal. So it would be, similar expression now. If I multiplied by 100 on left hand side as well as on the right hand side, so it would be same expression, right? Tell me.
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
I will just do that. I will multiply by 100 on the either side, on the both sides of this equation. Is it okay to everyone?
Yes.
Yes.
Yes, ma'am.
Okay. So you have the value of percentile error in A, which is 1%. So you can write it as 2 into 1% plus. You have percentile error of B. है ना? Percentile error of B, which would be half of 2%. Then you will have the percentile error in C, which is nothing but the 3%. Just put the values. And then you have the percentile error of D, which is 4%. So it is 3 into 4%. Just add them algebraically. So it would be 2% plus 1% plus 1%. See, 2% and these two will get cancelled out. These three will get cancelled out. So you will get 2% plus 1% plus 1%, which means 4%, and then 4% plus 12%. You will get 16% as your answer. Do we have this option over here? Yes, it's option C. Is it okay?
Yes, ma'am.
Yes.
Pakka? 100%?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Since you just said 100%, let's have this question. Now you still have time to change your answer. Is it okay to you? Is it clear to you? Or you want to change your answer? Huh? It's okay? बोलो भाई. नहीं आया समझ अभी भी? It is not clear to you? Okay, clear. ठीक है, cool. Cool. I am launching the poll for this question also. So please answer me over there only. And right now it's 18:26. Solve it by 1828. You have 2 minutes to solve this question. The poll is live now. You can answer the question. Is there any issue with the screen?
No, ma'am. It is visible.
Oh, okay, Shikha. Can you refresh it from your side, Bacha?
Okay, ma'am, let me try.
Okay. So time is up and I got only 2 votes. Yes, Harshita?
It's option B.
Okay. Now got the 3 vote. Who voted for option D? Okay, oh, that's nice. Let's solve this question. We have to calculate the density of a material which has a shape of cube, and it is determined by measuring 3 sides, okay, of the cube and its mass. If the relative error in the measurement of the mass and the length is this, okay, they gave us the value of, let me write it over here, delta m by m into 100 is equals to 1.5%, right? And the other detail which I have is delta L by L into 100 divided is equals to 1%. Okay? This is what I have. Now I need to calculate the density. Density would be mass per unit volume. Okay? And if I want to calculate the relative error, I think I should do this. Okay, just pause for a second. Since I have the information about the length, I need to change this expression in the terms of length also. So this volume can be written as m upon L cube now. The volume of the cube is the L times of, L raised to the power 3. Okay. So this formula can be written as this, like this. Again, I have percentile errors. So it would be nice if I multiplied the entire expression with 100. Like this. Okay. You will have the answers that percentile change array, that the percentile change in density would be 1.5 plus 3 into 1. And it would be 1.5 plus 3, and it is 4.5%, which is your option D. Is that okay?
Yes, ma'am.
Ma'am, can you explain it again?
Okay. See, in this question, we have the detail about mass and the length. Then density is mass per unit volume. we need to convert this expression in the terms of length also, no? Because whatever the data which is given to us, we need to include that into our solution somehow. Okay, so I know the volume of the cube is length raised to the power 3, so I just put it here. Now write it down in the form of that expression which I just told you. The delta rho by rho is equals to delta m by n into 3 times of delta L by L. In the given question, I have the percentile error. So I need to convert this relative error into percentile error by multiplying the entire expression with 100. So I did that. I got the percentile error. Is that okay, Harshita?
Yes, ma'am.
Okay. So do you have any class after this session also, or it's just this is the last class?
Ma'am, it's the last class.
Okay.
No, ma'am.
So I want to explain you vernier calipers and this instrument basically. Vernier caliper is an instrument which is used to measure the length. Now you would say, ma'am, why do we need vernier caliper when we have this ordinary scale? If we have this ordinary scale, why do we need vernier caliper for it? So the reason is because let's say I gave you a rod and I know its length is 6.54. Okay, I gave it to you. Some of you will give me the answer, ki, ma'am, the length of the rod is 6.5. Some of you will give me the answer, it is 6.6. But the actual answer is 6.54. Okay, but your device which you have, that ordinary scale, that is not applicable to calculate the length beyond 1 decimal place. It cannot calculate. The least measurement which an ordinary scale can make is 0.1 centimeter only. Yes or no?
Yes, ma'am.
So either you can calculate 5.5 or you can calculate 5.6. There is no in between. But I know that the rod which I gave you has the length 5. Let's say 5.6 or something. So to get the more precise measurements, more precise results, and hence the conclusions, we need some other devices, and vernier caliper is one of them. So in 99% cases which you will deal, have this simple setup, okay? And to be very honest, the frequency of this topic in your exam is very low. So I will forget that 1%. I will focus on 99% wala chances. Okay. You have this kind of structure. As you can see over here, I have an imperial scale, which is also known as the main scale. Okay. This main scale is nothing but your ordinary scale. Okay. This scale is nothing but your ordinary scale. Then you have this thing. Are you able to see it?
Yes, ma'am.
Yes, ma'am.
Okay. So this is the spatial scale, and it is known as vernier scale. This end, this jaw is the fixed one. It is the fixed jaw. And this one is the movable jaw. Okay. I want to draw your attention towards 3 parts of this vernier caliper. One is this external jaw. Second is this internal jaw. And the third one is depth measuring blade. Why I'm talking about these 3 particular parts? Because these 3 particular parts hold the 3 different applications of this device. From this device, you can calculate the length, breadth, and height of any regular object or diameter of some object by inserting that object in between the external jaws. Okay? See, just look at this particular figure. I want to calculate the dimension of this fixed jaw, of this screw. So what I did, I put this screw in between the external jaw. As you can see, this sliding jaw is something that you can slide over. You can make the room for your object, okay, by sliding it. Once you get the appropriate result, the appropriate distance, appropriate separation, remove the object and calculate the length, or just study the reading. I will tell you how we will do that. But for timing, do you get the idea how to measure any object, its length, breadth, or height?
Yes, ma'am.
Okay. Now let's talk about the application of these internal jaws. Now for an example, I want to calculate the thickness of a beaker. I'm not interested in the dimension in the diameter of the beaker. I want to calculate the thickness. So for that, what will I do? First, I calculate its outer diameter. See, this is now how a beaker would look like. This thing. There would be some thickness to it, right? Right? So I just want to calculate this thickness. What will I do? First, I will put this beaker in between the external jaws to calculate the outer diameter. Once I've got the readings, I put it aside. Then I do bottom up this beaker and put it over the internal jaws. Over the internal jaws. Now I will slide this scale and these internal jaws will move apart from each other. Once I got the dimension of inner diameter, what will I do? Outer diameter minus inner diameter, that would be the thickness of the beaker. Yes or no? You can see this diagram also. For example, I want to know the size of this cavity. What would I do? I put it in between, I will put it over the internal jaws and then I just slide this scale to get this thing. Are you getting this thing? This idea?
No, ma'am.
No. See, I gave you a task. Please give me the size of this cavity. So what would you do? You just insert the internal jaws into this cavity and you just try to get the size of it by sliding the vernier scale. See here. Okay, I cannot write. Can you see this upper wall diagram? Here, we move the jaws away. You get the size of this cavity. You will get some reading over this scale. So this is the second application. Is it okay now?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Now come to this depth measuring blade. What if I gave you a beaker and I ask you to find the depth of that beaker? What is this D? So what will you do? You will move this vernier scale and try to touch the tip of this blade with the bottom of the beaker. Okay, something like this. Like this. See, this is depth measuring blade, right? This one. And I'm just trying to touch the tip of the blade with the base of the object. And whatever the reading you will have, that would be the depth of that object. Yes or no?
Yes, ma'am.
This one diagram concludes the entire application of this vernier scale while measuring the outer diameter, inner diameter, or the depth of that cavity. Okay, so that's how we will work with this vernier calipers. Now you have a imperial scale. Don't go with this name. Okay, don't need to remember so many names. It's okay if you remember the main scale. Main scale is nothing but your ordinary scale. Again, this centimeter one. Okay. And this vernier scale is the special one. So why is it special? What are the speciality about this? We will discuss it. Let's come to the application, uses of this topic. As I already told you that we can measure the length, breadth, and height of a small regular object. We can measure the diameter of the cylindrical body or the spherical body. We can measure the depth of the beaker, and we can measure the internal diameter. So I think this slide is okay to everyone.
Yes, ma'am.
Cool. Let's come to the vernier caliper. So I've already mentioned about the main scale, vernier scale. Now just focus on this thing over here. Can you see that there are 10 divisions? Let me, zoom it out, zoom it in. Okay. Okay, can you see it?
Yes, ma'am.
So I guess it is visible to you that the 9 divisions of main scale is equals to 10 divisions of vernier scale division. Is it yes or no? Are you getting it?
Ma'am,
Yes.
can you repeat?
Yes. See here, a second. Here, 10 vernier scale divisions are equal to 9 main scale divisions. See, 0, 1, 2, 3, 4, 5. This is the 9th division. And on vernier scale, it is your 10th division. Is it okay?
Yes, ma'am.
Okay. So that's what I wrote over here. The 10 vernier scale divisions is equals to 9 main scale divisions. Generally, you have this kind of setup. This is your 99% cases. That main scale divisions are always, greater than the vernier scale division. As you can see over here, that each division of vernier scale is smaller than each division of main scale. Is that okay to you?
Yes, ma'am.
Okay. Now let's calculate the least count. Least count is that measurement which is the smallest one any scale or any of that particular measurement device can do. For example, the 0.1 centimeter is the least count of ordinary scale. That is the smallest distance which you can measure completely, perfectly with accuracy by that ordinary scale. That is 0.1 centimeter. So least count is that number. Are you understanding? Are you get the idea of least count? Ki kya hota hai? Are you getting the idea of least count? Cool. So least count is equals to 1 minus m by n main scale division. We are not going to deep down to how do we get this formula, because that is not something very very much required to our discussion, to be very honest. Here m is the main scale division and n is the vernier scale division. Okay. For an example, in the above case, I got this relation that 10 vernier scale divisions is equals to 9 main scale divisions. So on the basis of it, the value of m is 9 and the value of n is 10. So you can calculate the least count in such case by 1 minus 9 by 10 into 1 main scale division. What is the value of 1 main scale division? I guess 0.1 centimeter. See,
Yes, ma'am.
here you have how many divisions? From 0 to 1. See, from 0 to 1, you have basically 10 divisions in between. So that's how I get the idea of 1 main scale division. Okay. So that is 0.1 centimeter. I guess you just calculate it and you will get the answer. It is 1 by 10, 1 by 10, 0.01 centimeter. See, now this vernier scale can give you the data beyond 2 decimal values, beyond 2 decimal places, right? This is more accurate, more precise than ordinary scale, yes or no? Because that is going only 0.1 centimeter. It can measure 0.01 centimeter. So it can give you the right idea about that length of the rod, which is 5.54 centimeter. It can give you the answer. Okay. Bolo,
Yes,
samajh
ma'am.
aaya? Okay. Now, the last topic of today's lecture is how to take the reading of vernier scale. So in the blue, I draw the main scale. In yellow or orange, whatever the color is, I draw the vernier scale. While noting down the reading of this of any measurement of any object or whatever the object you want to measure, just do one thing: main scale reading plus vernier scale reading. Main scale reading is the reading on main scale before the 0 of vernier scale. Matlab, just wait a minute, let me zoom in. Okay, can you see it? The 0 of the vernier scale is over here, right? This is the 0. Yes?
Yes, ma'am.
Okay, the 0 is something here, and then we have few more divisions. So before this 0, I think this reading on main scale is visible to you now, 1.1.
Yes, ma'am.
So for me, 1 minute. So for me, the main scale reading is 1.1. It is the reading on main scale before the 0 of vernier scale, which is visible to you. So that is 1.1 over here. Now plus the least count of the vernier scale, which you just calculate 0.01 into number of that division which is coinciding with the main scale. Among these 10 divisions on vernier scale, there must be a one division which is coinciding with the main scale. Like again, I'm going to zoom in over here and you have to tell me the number of that coinciding division. There must be a division which is, oh, that is so much. Yeah, okay. Here, you must have one division in such a way that it is coinciding with the main scale. One vernier scale division is coinciding with the main scale. Can you give me the number?
5.
Very good. Very good, Aditya. It's 5, this one. This is the first division which is coinciding with the main scale. So you have to answer, you have to write it like this. Wait a minute. Okay. Just write it 5 over here. And the reading would be 1.1 plus 0.05, which means 1.15 centimeter. This is your answer. Is that okay?
Yes, ma'am.
Okay. So that's it. With this question as your homework, I will end the class. This is your homework. Kindly take the screenshot. Otherwise, I'll share the notes. In next class, we will discuss about the screw gauge and we will practice few questions over it. And this is your homework. Okay, this is your homework.
Ma'am, will you share the PDF on the group?
Okay, I'll do that. And yeah, these are homeworks. Just make sure you go through this slide. Next day, we will talk about the numericals of this chapter, which includes screw gauge and kinematics. This is your next chapter, which we will deal. Okay, make sure that you will do this pre-work. See, please don't wait for my message on the group. I will message you before the class. I always give you the pre-work in the present class. Okay, so whenever we will have next class, I want you to go through these topics. Okay, so that we can do the numericals. Thank you so much for being so nice. It means so much to me. Okay, I'll see you in the next class. Have a nice day. Nice day, though. Have a nice time for though. Bye.
Ma'am, today's attendance?
Attendance is there's going to be a link, right?
Yes, ma'am.
Okay, I'll ask about it. Just wait.